Hello guys, welcome back to my YouTube channel. So for today's video, I will do a tutorial in chapter 4, which is network access. To support our communication, the OSI model divides the functions of a data network into layers. So each layer works with the layer above and below to transmit data. Two layers of the OSI model are so closely tied that according to the TCP/IP model, if they are in essence one layer, those two layers are the data link layer and the physical layer. On the sending device, it is the role of the data link layer to prepare data for transmission and control how the data accesses the physical media. However, the physical layer controls how the data is transmitted into the physical media by encoding the binary digits that represent data into signals. So, on the receiving end, the physical layer receives signal across the connecting media after decoding the signal back into data. The physical layer passes the frame to the data link layer from the acceptance and processing. This chapter begins with the general function of physical layer and the standards and protocol that manage the transmission of data across local media, and it also introduced the function of the data link layer and the protocols associated with it. So as you can see, we have here the types of connection, and we have here the home router. So we have here the 4 Ethernet switch and 1 Ethernet connection, and then the embedded wireless antenna. So whether connecting to a local printer in home or website in another country, before any network communications can occur, a physical connection can occur. A physical connection to a local network must establish. A physical connection can be wired connection and using cable, or a wireless connection using a radio waves. So here, the type of physical connection used to independent upon the setup of the network. For example, in many corporate offices, employees have desktop or laptop computers that are physically connected via cable or shared switch. This type of setups wired connection data is transmitted through physical cable. So we will physical to. So as you can see, we have a connected to the wired LAN. So we have here the as a home router, we have here the for Ethernet switch, so we can use one of those. So we will unplug some wire. So we will use for example, we will use a UTP cable for us to connect the router and the laptop. So we have here the wired connection using Ethernet network interface cards. Then connect a device to the network. Ethernet NICs are used for wired connection as shown in figure 1. So as you can see in figure 1, it can connect it to the wireless local area network and are used for wireless. An end user device may include one or both types NICs. Network printer, for example, may only have a Ethernet NIC and therefore must connect to the network using Ethernet cable. Other devices such as tablets and smartphones may only contain an WLAN NIC and must be used a wireless connection, because for the smartphone and tablets, it cannot be connected through um, wired connection, because it has no wired ports, so we will not plug it, so we will use a wireless. So figure 2. So as you can see, this is the example of the wireless LAN with a range extender. So as you can see, we will in this figure, it use some wireless router, and then the end device will be the wireless laptop, wireless smartphone. So it can connect to the wireless router. It cannot use some wired connection like um, PC to connect to the wireless router. So from the word wireless, so it cannot be put some wireless in the wireless router. So you can connect it without wireless. So the physical layer, the OSI physical layer provides the means to transport the bits that makes up the data link layer frame across the network media. This layer accepts the complete frame from the data link layer and encodes it as series of signals that are transmitted into the local media. The encoded bits are comprised a frame are received by either an end device or an intermediate device. So as you can see here, the source node. So we have a application, presentation, session, transport, network, data link, and physical. So here's the signal bits. So as you can see, we have a 1010 and so on, and then we have here the frame header data trailer. So it as you can see, it's example on chapter 3 activity. So here the source node. So the source node here go to the application presentation. It can go to the signal, physical, and to the destination node. So that's the cycle. So we have here physical layer media, and we have the types of media. So we have here the copper cable. We have here the copper cable, fiber optic cable, and wireless. So copper cable signals are patterns of electrical pulses. So it has a as you can see in the figure, it has a electrical signals in the copper cable, and then the fiber optic cable, the signals are pattern of light. So as you can see, for the fiber optic cable, it has a light pulse, and then for the wireless, it has the pattern of microwave. So physical layer standards. Protocol and operation of the upper OSI layer are performed in software designed by the software engineer and computer scientist. The services and protocols in the TCP/IP suite are identify the Ethernet engineering task for IETF. So as you can see, we have the physical and the physical layer standards implemented in the hardware and governed by many organizations, including ISO, EIA, and so on. So the TCP/IP standards are implementing software and governed by the IETF. And now we will answer this activity in chapter 4. So activity physical layer terminology. So we have here the instruction. Description of the physical layer are provided in the table. Drag each physical layer term to its description. So we have choices here. The fiber optic, we have bandwidth, and third, throughput, copper, and wireless. So we have here the physical layer description. We have here the excuse me media that uses pattern of microwaves to represent bits, the capacity of a medium to carry data, the media that uses pattern of light to represent bits, a measure of transfer of bit across the media that uses electrical pulses to represent bits. So it's easy to answer this because we already tackled it, and for you to do not know how to answer this, and I will teach you how to answer this. So first, we will read again the question. So media that uses patterns of microwave to represent bits. So first, for the we will use the wireless because wireless is commonly used in the wireless device such as laptop, cell phone. It use patterns microwaves. So the capacity of medium to carry data, so it is the bandwidth. So the bandwidth can carry data more, and then it has a capacity of a medium. So media that uses patterns of light represent bits. So easy to answer. It is a fiber optic. So the fiber optic has a light to represent bits, uses patterns of light. So measure of transfer of bits across the media. It is the throughput, and then and lastly, the media that uses electrical pulses to represent bits. It is the copper. So we will check if it is correct. So correct. You have successfully matched each physical layer term to its description. So we already answer it, and we are checking it. So it's all correct. And then if you have any more question, just comment down below. And thank you for watching. I hope you enjoy my video. And for more, if you have a more questions, just comment. We will answer that. And then thank you for watching again.